another example to understand the subset. Suppose students, we write a set A 3, 5, 7, 9 and 11, and now we write, suppose a set B, I write a set B in a set builder form, x such that x is an odd number, x is an odd number and x is less than 12 and greater than 2. Now student, if I write the set B in a roster form, what is the set B? The set is x is an odd number and is greater than 2 and less than 12. So the set 3, 5, 7, 9 and 11. We stop at 11 because the number x is less than 12 and greater than 2. So now you can easily observe the students, A and B sets have same element, having same elements, student. So here we can say A is the subset of B because every element of A is also present in B. But student, here every elements of B is also present inside A. So we can say B is also a subset of A. A is the subset of B and B is also a subset of A. Now students, we can say the set A and B are equal sets because they have the same elements. A and B have same elements. So if A is a subset of B and B is a subset of A, this can be possible only when. So this implies that A equals to B, students. So A equals to B, student, because these two sets A and B are equal sets, or you can say A equals to A or B equals to B. Now what is the conclusion from this result, A equals to B? So from this equation we conclude that every set is equal to itself. Every set is equal to itself. So we can say every set is the subset of itself. So we can say every set is a subset of itself, students. So this is the very important point. Every set is a subset of itself, because if you write the set A and compare the set A with itself, so set A equals to A because all the elements in set A contains in A, it contains in itself only. So every set is the subset of itself, which is clear from this example, because A is the subset of B and B is the subset of A. This is possible only when A equals to B, because these two sets are equal. So we can say every set is a subset of itself. So student, now let us take another example. I write the set C, suppose 2, 4, 6 and 8. Students, suppose this is any set, and let us take another set D. So student, you know this set D, this is the empty set we discussed earlier. Empty set is represented by curly brackets, no element within the curly bracket, or 5. So student, this is an empty set, and an empty set contains no element, students, and the set C contains some elements. So we can say if any element contains no element, then this set is present in every set. It is obvious, because any set contains no element, then this set present in any set. So element of the empty set are present in also C. So from this conclusion we can say that D is a subset of C, because D is an empty set or null set or void set, and empty set is a subset of every set. This is the important result. Empty set is a subset of every set. So students, the first important point is every set is a subset of itself, and the second important point is empty set is a subset of every set. If you have given a set, then the empty set is subset of this set. Like example, this, if C is any set and we consider any empty set, so the empty set contains no element, so it is obviously the subset of C. So empty set is the subset of every set, student. So this is enough for today, students. Now meet you tomorrow for next important topic.